Good morning.
Morning, Kim.
Good morning.
All right. Let's get back to work. Did you guys plot these points? Did you guys do the calculation? Okay, the first one should be easy, but may not be so straightforward because we're dealing with E, right? We're dealing with E. E seem to bother a lot of our students. What is E, right? You rather deal with 2 or 3 or 5 or 10 whole numbers. Come on, guys, 2E is just a number. Treat it as if it is 2. It is almost 2, almost 3. Of course, it's not. But it plays the same role. It's a base of an exponential function. It's a base of an exponential function. Okay. So once again, if you think of this as a function, so let me reiterate the function as a rule, right? Input output. Output, input, output, input, output. Do you guys follow me? We started with this theme at the beginning of the semester, and we will end with it. Okay, this entire class is the theme of function. What is a function? So you fully understand the definition of function completely. That's what we need. That's what we need. Okay. And we will closely follow the grammar of mathematics as we talk about at the beginning. 2 kinds of sentences. One is a statement and one is if statement. That's it. 6 principles. 6 principles, all spelled out. Do you guys have all 6 principles with you on flashcards? Can you show me? Could you guys show me the 6 principles you have put on the flashcards? Everybody, so please turn on your video. Turn on your video. We have 21 participants. Okay, very good. Okay, you have it handy. You have it handy. Carolyn, Cortland, Bailey. Okay, good. But this is only 1, 2, 3, 4. How about the other 16? Where are the other 16 people? Where are your cards? Could you show your happy face to me? Could you show your happy face to me? All right, I got 4 of you. But where are the other people? Okay. Andy, where's Andy? Where's Aaron? Kevin? Kyle? Jocelyn? Linara? Soleil, Michelle, Mikhail. Where is everybody? Could you show your pretty face to me? Tiffany, Mari, Jess, Jessie, Bailey. Oh, Bailey's here, sorry. Bailey is here. I need to see more faces. Come on, guys, come on. Are you hiding from me? Are you hiding? That's interesting. I know some people may not have the, webcam to show, your face, but how come we have so many people who don't show? Oh, there. Okay, Tiffany's there. Drake, Kevin. Okay, let me make this larger. There we go. Andy's there. Aaron's there. Mikhail, can you show me your flashcards? Show me your flashcards. Okay, we talk about 6 principles. Function definition. 6 principles, function definition. Okay. 2 kinds of statements in mathematics. One is a statement and the other one is if statements. Very good. Okay, so I see more people. Very good. I'm so happy to see you guys. Hi, everybody. You guys are amazing. Do you realize how amazing you are? You got up in the morning and you study for your future. You study for your future. Okay, this hard time will pass, but you will be prepared. You will be prepared for the future opportunities. Okay, this math is going to help you, to achieve your goals in life. Okay, so that's what we're here for. All right, guys, thank you so much for showing me your face, and let's continue. Are you ready? Okay, feel free to show your face here, video here, because I have 2 screens. So I can see your very good job. Okay, 6 principles, 1 function definition, and 2 types of sentences. Okay, now, so this is the function, that's the input, and that's the output. Right? So you can see this rule. A function is a rule that assigns each element in the domain exactly 1 element in the range, right? So over time, you'll be able to speak it. Okay? And you speak it like matter of factly. Okay? Now, next, we have talked about the domain, we've talked about the range, right? So let's see some more concrete things. For example, yesterday, I put the table -1 on the top and -2 in the bottom. I reversed the order because I like it to be perfect. I like it this way, okay? So if you will, please just switch it for me. I will explain to you why I do that. I will put the number in the order as they show up on the number line, from small to large. Do you follow me? -2 is smaller than -1. -1 is smaller than 0. 0 is smaller than 1. 1 is smaller than 2. So I put it in that order. Does it matter? Well, it doesn't matter terribly, but it does matter. It helps us see patterns better. It helps us see patterns better, okay? So now we see e to the power -2 is 1 over e squared. What is 1 over e squared? And what is 1 over e? E to the power -1 is 1 over e. Anybody have questions about the negative exponents? Anybody has questions about negative exponent? Well, yesterday at office hours, someone came to my office and we were discussing what is 1 over e. 1 over e is just 1 divided by 2.7 followed by infinite number of digits. Your calculator will typically do it for you, and the numerical value is about 0.37037 followed by many, many digits. Okay, so you have a sense that 0.37037 is approximately the value of 1 over e. Okay, and the other perspective I wish to give you that yesterday we talked about e is less than 3, larger than 2, right? If we put a reciprocal for it, what happens to 1 over 2 1 over 3, 1 over e? What will happen here? What is the relationship? The relationship will be reversed. Okay? Think of function, think of this function that we learned, we have reviewed. You guys follow me? So what I'm trying to tell you that this relationship tells us that 1 over e is just a number between 1/2 and 1/3. You follow me? Does that help us to see better? It's just a number. It's a number between 1/3 and 1/2. So when you plot points, when you plot the points, you could approximately find that position. You follow me? Okay. Sometimes some of us get stuck with it. You say, oh, what am I going to do? 1 over e. What is 1 over e? Well, 1 over e, if e is a number between 2 and 3, 1 over e is a number between 1/2 and 1/3. Does that help? Okay, so now we know 1 over e is a number between 1/3 and 1/2, and then what do we do? Well, what do we do next is that, okay, if you really, really want to know what 1 over e is, it's about 0.3. It's about approximately 0.3 or 0.4. Okay, that's it. So for the same idea, you can figure out what is 1 over e squared. What is 1 over e squared? What is 1 over e squared?
-2.
1 over e squared, if you square every side like this, okay? I want you to put away your calculator. Really do this with me. You really would need this in your calculus class to be able to operate these things. Okay? You square every side, what you get? You get 1/4 larger than 1 over e squared larger than 1/9. Did I mention to you earlier that 99% of all college students I know, they have a hard time with inequalities. And so this is our weak point, okay? So intentionally, every opportunity I have, I will show you how to handle inequalities. And for you, you will work on it. You first follow my examples, and then you start to grow from it. Over time, you will get better. Trust me, you will have to handle inequalities in Calc 1, Calc 2, Calc 3. Okay? In Calculus 2, there's a very difficult chapter called sequence and series. That chapter is very, very difficult. Okay? You will need to handle some inequalities from time to time. All right, so the skill you learned today is not going to be wasted. It's not going to be wasted. Okay, so what can we tell? We can tell that 1 over e squared is between 1/4 and 1/9. This will help you. This will help us to approximately find the point. Find the point. So when you do it on paper by hand, you just approximate it. You really just approximate it. Okay. When you do it by hand, we're not asking you to get a precise position because no one can get a precise position. But you want to see the pattern. You want to see the tendency. Okay, so you just approximately get the point correctly. Okay, so let's do it. Let's do it. So so if you really want to know what is 1 over e squared, as a decimal, okay, so I'm showing you two perspectives. One is a fraction perspective, one is a decimal perspective. The decimal perspective would be numerically, it doesn't give me that value. Can you use your calculator to do that? Uh, 2.7 what? 7183. I'm just gonna copy that number. This is probably the only time you get to go over this. Someone go over this with you in your math class. Once you're in calculus class, or you get to 4-year schools, your professors there will not have time to do this for you, okay? You have to do it yourself. So just get it over right now. There. You follow me? You don't need to get stuck on it. You just need to know this number is between 1/4 and 1/9, and it's approximately 0.13 if you really want to get to the bottom of it. All right, so take this number. You can put it here if you wish. But the output is a positive, isn't it? The output is a positive, 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 positive. Input a negative, output a positive. You can also imagine, okay, this is a time we're gonna put on our thinking cap. Oh. Okay, this is the moment we're gonna put on our thinking cap. Imagination, okay? We start to imagine. We start to imagine. What if this is a negative 10? What if this is a negative 1000, right? Remember what we did with 2 to the power of x? Remember that?
We just make it a fraction.
Okay, this is negative 1,000. This is negative 1,001, right? That's right. It's going to be a fraction, but what kind of number would that be?
You mean a positive?
It will still be positive. Very, very, very good. Okay, the value will still be positive, right? And what is it? It's going to be e to the power, oh, sorry. It's going to be e to the power of what? Negative 10. What is e to the power negative 10? It's 1 over e to the power 10.
Mm-hmm.
This number, how big is this number? What is it in between?
2 and 3.
Well, you can continue this process, right?
1 over 2 to the power of 100, right? You just put it in that.
Let's do it. Let's do it. Isn't that fun?
Yeah.
You know what? I'm going to make a table next to it, okay? Because this is a little awkward. Okay, I'm going to insert a table here with rows. Okay, since we're dealing with numbers, maybe we just, you know, get to understand this, right? So E is larger than 2, smaller than 3. Okay, so 1 over E is larger than 1/3, smaller than 1/2, right?
Mm-hmm.
Let's keep going. We did for 1 over E and we did it for 1 over E squared. Can you do it for E to the power negative 10?
Yeah, you just put them in the.
Okay, so what do you see? I really, you know, like the fact you're following me and you're getting it, right? So this is going to be greater than what? Smaller than what? 1/2
To the power of.
to the power of
10.
Yes, good job. And the other side, what would that be?
1 over 3 to the power of 10.
Perfect. Perfect. Positive. Right? What you see is the output is still positive. Right? But what is 1 over 3 to the power of 10? Well, this is just going to be 2 to the power of 10 under 1. Right? And this is going to be 3 to the power of 10 under 1. What's the size of this number?
It's really, really small.
Very, very small. Is it larger than 0 or smaller than 0?
It's still larger than 0.
That's right. Still larger than 0. So no matter what's the input. So let's see what is, can you guys work on this negative 1,000?
Do you want the answer?
Yeah, however you want to tell me.
1 to the power of 1.
This is going to be larger than what? 1 over 3 to the power of what? 1,000. It's a very small number. You agree, right?
Yeah.
But it is still positive. It's still larger than 0, isn't it?
Yep.
Larger than 0. Larger than 0. Larger than 0. Okay, on the other side, we don't really need it because you can do it if you want. How about negative 1,001?
Just 1.
You get it? Did you
Yeah.
get it?
Yeah.
So this number, you just copy, paste,
Change to
And this
0.
is 1001. 1001. Is it still positive?
Yep.
Doesn't that confirm? If you keep going, see negative 10,000, negative 2 trillion, are you going to get any number that's equal to 0?
No,
No. And what does it tell us?
that it can never be 0.
This tells us the range. Okay, this is confirming the range of e to the power x is positive forever. Do you follow me? Does it look real now?
Mhm.
Does it look real now?
Mhm.
Great, wonderful. Okay, so no matter what this is, then you're getting these, and so all of these input we're not going to do, right? The input, okay, the input is going to be negative 1001, and the output is going to be positive. Okay, and this input is negative 1000, the output is what? Is positive. And this guy is negative 10, and the output is going to be what? Positive number. So small and so close to 0. Okay, so I'm going to use a notation you're going to use very often in math class. Like that. Could you do that for me? Just copy that exactly and tell me if you understand that symbol. Do you understand that symbol now? You've seen it more than once, right? You've seen it more than once, and you will see it many more times in Cal. Okay, what does this mean? A number larger than 0. A number larger than 0. A number larger than 0. Do you follow me? I just want you guys to get used to that notation. Get used to that notation. Okay, and if you are to compose these points, can you compose these points? Okay, you probably only need to do this once in your lifetime. Can you do it for me? Can you do it for me? This thing. Can you do it for me? Just put them in there so you understand. Does everybody follow me? Larger than 0, larger than 0. All of these larger than 0. So I'm going to use a new notation here, approaching 0 plus. So you learn your new notation. It enhances our understanding. And you will be, I assure you, you're going to be using these notations in calculus classes. Okay, so without further ado. So we're not going to plot these points because these points are so close to x-axis, but now we can imagine them. Can we imagine them? We can imagine them. Okay, so they're way over there. They're way over there. Okay, so these are the practice. So are we ready to plot our points? Let's plot our points. Okay, so I know some of you have done it. Okay, so how about e squared? How about e squared? Well, e is between 2 and 3, right? E squared, what is e squared? E squared is larger than 4.
It'd be between 4 and 9, right?
That's right, it's between 4 and 9. Okay, if you really want to get e squared, you can just get the numerical value. Yes, you can, right? So now, do you think e still bothers you? Not anymore, not anymore. Okay, that's what I hope. So next, I want you guys to plot all of these points. You have not. Okay, I want you guys to plot all of these points in the graph. Okay, where's my graph? This is my graph. If you haven't done so, if you have done so, if you have done it, okay, yesterday I plotted 1, e. So today I'm going to plot some of the other points. You need to mark all the points. Do you follow me? You need to mark the point. Remember how we mark the points for 2 to the power x? You need to mark those points, okay? So 0, 1, the red dot, okay? And adding -2, -2, 1 over e squared, e squared, and -1, excuse me, -1, 1 over e, and one more point, that's 2, e squared that I need to put in there. That's all the points. Do you follow me? So what we've done here is that for those other numbers, such as -10, -1000, so that will allow us to put on our imagination, put on our cap of imagination, is as x approaching -infinity, what happens?
Gets closer and closer to 0.
That's right, the output is getting closer and closer to 0, but it will never be 0, isn't it? It will never actually be 0, but it just getting closer and closer and closer to 0. Guess how we express that in mathematics? This is how we express it in mathematics. Okay, it says as x approaching -infinity, e to the power x approaches 0 larger than 0. That's already calculus. That's already calculus. Do you follow me? All right. So this allows us the imagination. But what I want you guys to do, I want you guys to mark these points. Okay, I'm not going to mark all the points in class because that would take a lot of time. But I'm going to show you an example how I want those points marked. You've seen those examples when I did when I did for 2 to the power x, I marked each one of those points, right? So I want you to do the same. So each one of the point, hold on, my bad. So each one of the point, okay, each one of the point is marked. So this will be marked, okay? So I'm gonna show you more examples anyway, okay? So this point will be marked as 1, e, and this point will be marked as 2, e squared. Okay, and this other point, this point will be marked as -1, 1 over e. And this other point will be marked as -2, 1 over e squared. Okay, this is how I expect you, each one of you, to mark these points. And then finally, we're going to connect the dots. Connect the dots. Connecting the dots is the easiest thing to do, right? Right? Is that good? Do you think by this time you thoroughly understand domain and range? And you even visualize domain and range, do you? Domain are those input on the horizontal line, the output are what? The vertical. Okay, the verticals are, and so visually you will see that this is the output, 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 and then of course there are other output in between, right? We just didn't show all of them. So you can see clearly as x getting to negative infinity, the height is approaching to 0. Do you guys see that? That's the visual. That's the visual. That's what it says. But what happened to the other direction? What happened to the other direction?
It's infinite.
So if x approaching positive infinity, what happened to e to the power x? What does it approach to?
Infinity.
That's right. That's the perfect answer. Right? As x going in the other direction, that's x approaching positive infinity, e to the power x approaching positive. You're already doing calculus. You are already doing calculus. The foundation of a calculus is algebra. The foundation of the calculus is algebra. That's why we want to build it on rock. Okay, so I'm waiting for everybody to write the notes, write down the notes, and then we're going to move forward. Okay, we're going to move forward. So far, so good? Anybody has any questions? Let me check on the chat. Oh my God, there's 8 messages on chat. I'm so sorry, guys. I overlooked. Okay, I'm so sorry, guys. I forgot to look at the chat. Okay, that's fine. You guys are explaining to me why you cannot show the video. That's fine. That's okay. As long as you're there, you're doing the work. And I appreciate each one of you. Okay. All right. So can I erase all of these? Okay, so I'm going to clean out. Let's move on to logarithm, right? This is the more exciting part. This is the more exciting part. Okay. Logarithm. Okay, I'm going to remove this because we did this in office hours. Okay. What is ln of -1? I cannot see your screen. You cannot see my screen. Hold on. Can you see my screen now?
It's undefined.
Okay, very good. Why is undefined?
Because no matter what, you can't get a negative.
Can you type your word? Your answer is right, but I want to see the reason. Jessica says she cannot see the screen. Do you see the screen now, Jess? Jessica? Okay, she will try to relog in. Why it is undefined?
It is.
What is ln? Oh, sorry. I'm so sorry. Okay, I'm gonna read. Oh, sorry guys. I'm terrible. Where are we? I'm sorry, guys. I'm gonna get back where we should be. Okay, so here we're working on this table. We're working on ln. Okay, we're working on ln. Okay, I just want to clean these up. And I ended up we have those already. First of all, I want to emphasize ln is a function. Okay, ln is a function. Okay, so this time we're gonna do g of x ln x. Okay, just be reminded, ln is a function. ln x is a function. It takes the input. Okay, and that function has a rule. That function is a rule. It produces output. If it is a function, for every input in the domain, there must be a unique output in the range, right? There must be a unique output in the range. So now let's see what is the rule. What is the rule? Do you guys still remember what is the rule? Some of you may have forgotten about logarithm, right? But that's okay, that's what we're here for. By the time you're in calculus class, it will be absolutely unforgivable if you don't remember logarithm definition and their properties. But now it's okay. Okay, that's what we are here for. That's why we have pre-calculus. We review this. Okay, so we're going to review what is this rule. This rule is a little bit more complicated. Okay, because this rule is related to another rule. Okay, what it says is that ln x, the output, suppose the output is a triangle. If and only if and only if e raised to the power triangle must be equals to x. You follow me? Now, for the input of -1, if we have an input of -1, the output corresponds to input of -1 must make this true. So can you identify that output for me? What happened?
You can't get that because
It's not, yeah.
That's right, very good. Because we just discussed e to the power x, right? E to the power x is always positive. So what happened to this? No solution. Because e to the power of anything, triangle, square, any number you put there, it's going to be positive forever. So this will never happen. This can never happen. If this can never happen, you don't have the triangle. You don't have the triangle, you don't have the output. You follow me? So for this input, there's no output. Therefore, this number cannot be in the domain. So all trace back to definition of function. You guys follow me? It all trace back to that magical sentence. That all-powerful sentence. Now, so that's why it's undefined. So you're not going to have a point there. How about 0?
Undefined as well.
That's right. Perfect answer. I think you already foresee what is going on, right? It's the same reason. If you give the input for 0, right? And you need to have e to the power of something equals 0. But e to the power of something is always a positive. Therefore, you never have a solution. It will never happen, not in a million years. As a result, 0 cannot be in the domain because it doesn't have a unique output for it. So now I want you guys to read the definition of function again. Please, everybody. Okay, just like you're taking a moment to reflect on the definition of function one more time. When you read this definition this time, do you think you have understood much more than you used to? Do you follow me? Are you reading the definition? A function is a rule that assigns each element in A exactly one element, f of x in B. And A is a domain, B is a range. So now we will say for the input 0 for log natural log x, undefined. Okay, so not in domain, not in domain. Okay, how about 1 over e to the power of 2? This is the e to the power negative 2 I meant to give you. What is the output? Yesterday we got some answers. Okay, we got some answers. But if you still haven't got those answers,
It's, you want them? The first one for e
Sure.
squared, e negative squared is 1. It's gonna be, fuck, my bad. It's gonna be -2. That was gonna be
very
negative.
good, very good. You're absolutely right. Okay, but I'm going to explain to you why. Okay, using the same definition, if the input is e to the power negative 2, right? This is e to the power negative 2, and you will need your output to be e to the power negative 2. And what is that? What does that triangle have to be?
It has to be.
It has to be negative 2, right here, right? You want e to the power triangle, e to the power equals to e to the power negative 2. The triangle has no other choice but to be negative 2, isn't it?
Yep.
Do you guys see that? Do you see that? Does everybody see that? Right? That is following the rule. So this is actually e to the power of negative 2. And the answer is negative 2. That's the output. Input is e to the power negative 2. Natural log e to the power negative 2 is equals to negative 2. Okay, I'm going to make this just a little bit larger because I'm worried that you may not see the negative sign. Do you see the negative sign here on the shoulder? Okay, so how about natural log e to the power of -1?
-1.
That's right. You actually like that exponential form, don't you? So then you're going to compose your points. So could you guys write down those points? So the input is e to the power negative 2. E to the power negative 2 is positive. The output is negative 2. Okay, and this input is e to the power negative 1. Okay, be patient with yourself. These functions are very important functions. We want to make sure we understand them completely. Okay, now ln 1. What does ln1 equal to?
Zero.
0.
Very good, excellent. I think you guys are getting it. Okay, you have reviewed well. Okay, when the input is 1, the output is what? 0, because e to the power 0 equals what? 1. Right? Didn't we learn that in algebra class, b raised to the
Uh-huh.
power 0 equals to 1? Did we learn that? But that
Yeah.
has a condition, b cannot be equals to 1. B cannot be
0.
equals to 0. Remember you learned this in algebra class? And now the base is e. E is 2.7, blah, blah, blah. Therefore, it applies, right? So
Yep.
ln1 equals to 0. You will actually having these values in your calculus class from time to time, and maybe in calculus too. Okay, a little one step. Okay, so let's compose this point. 1, 0. So can you complete the rest?
Yeah.
Has it become so much easier?
Yep.
Yes.
Okay, so what does ln e equal to?
It equals 1.
I haven't seen this. I see a comments. Okay.
Uh.
I see some comments. Very good. Okay, hold on. Okay, you guys go ahead and complete. I'm going to check on the comments on chat. Okay. Domain is all positive real numbers. Perfect. Yes, Cortland. Kevin, you guys are ahead of us. Wonderful. Wonderful. I'm so happy to see those. Okay. Okay, I can see it. Thank you. Vertical asymptote on the y-axis. This is the inverse of the last one. I hope the last one you meant e to the power x. If that's so, that's perfect, Aaron. I haven't seen this algebra because my teacher had a seizure and we were flip-flopping with teachers. Okay, I'm sorry to hear that, Sena. Sena, you may not be alone. Okay, even though you have a special circumstances with your teacher,
Why?
a lot of the teachers, they may not do this in class, even though they're teaching regularly.
I
Bad. Don't feel bad.
learned Common Core. I didn't learn like real algebra, so I was just lost regardless all the way up until I got to like algebra 2. So I really don't know what's going on here. And I didn't take my medication, so I'm really just so lost and all over the place today.
Oh, you lost today.
Yeah, you lost me yesterday towards the end. It started throwing me off, but everything else I get, except for this part, of course.
Do you understand it now?
No, but I'm gonna try and go on Khan Academy and pick up where I left off.
Okay, this is about the definition of logarithm. Okay, or maybe you come to my office hour afterwards. Okay.
Okay.
Would you do that?
Yeah, I'm gonna try.
Okay, so right now just write down. So what is ln e?
1.
And that's 2, right? You guys got it.
Yeah.
And the reason is, right? So I'm still trying to make everybody understand. So please follow me. If this, right? So this is, let's go back to the definition. Okay, this is the definition. That's the rule. Okay. I mean, to take this class, you need to, ideally, in the ideal world, you should have had intermediate algebra trigonometry. Okay, I don't know who was speaking earlier. May I have your name, please? Or you can just private message me. If you didn't have this before, I wonder if you had a trigonometry. I think we're gonna talk in office hours. Okay. I don't want to embarrass you in any way. So here, so it's E comma 1. So when the input is E, right? So we want this out, we want this to be E. So how we make this true? Well, E to the power triangle should equal to E to the power 1 because E is E to the power 1. Does that agree with everyone? Okay. And if the input is E squared, right? And this is to be, you want it to be squared, therefore the triangle is going to be 2. So the last point is going to be E squared. Well, this certainly is not the last point on the graph. It's just the last point we want to do. And next, we want to have a sense of what these values are. Do we know what these values are from what we did earlier? Right? What we did 1 over E squared is between quarter and ninth. And 1 over E is between half and third, right? And E is between 2 and 3, E squared is between 4 and 9. Do you guys follow me? So now I want each one of you to put these points on your graph. Okay. Oh, how did I get this? Never mind. It's actually even better. We can compare these two. Okay, so what I'm going to do, oh, how come? Interesting. But anyway, so what are we going to do is we're going to graph the same thing. I'm sorry, we're going to graph the points on the same graph right here. Like we did, like what we did with 2 to the power x. Okay. So I'm going to just make some adjustments so I can put the points there. Y is going to be from -3 to 8. Now I'm going to make the x just a little bit to 9. Okay, so now I'm going to plot the points. I'm going to plot the points. Okay, and I trust you guys do the same. So E to the power -2. Output is -2. Red dot. E to the power -1. One comma 0. E comma 1. E squared comma 2. Okay, and mark those points. Okay, I will lead you to mark these points. Okay, and now I'm connecting the dots. Connecting the dots. This is what I'm going to do. Okay, I want to show you exactly how I want you to mark the points because I will perform. I will do what I preach. Okay, these points are we marked. Okay, -2. I'm going to make the fonts smaller. Can I make the fonts smaller? It's just so big. Make the fonts smaller. Anyway, it's okay. It seems, okay, I'm not gonna bother. -2 e to the power -2. Okay, on this side, there's the e to the power -2. -2, comma, -2. Okay, another point, this red dot, okay, I'm gonna skip because it's gonna make it look a little bit messy. This is the 0, 1, and this is 1, 0. Okay, and this one is 1, e, and this guy is gonna be e, 0, e, 1. And this is 2, e squared. E squared, 2. Is it everything absolutely clear? So now, if I ask you what is the range of ln x, what would you tell me?
Ranges are real numbers.
Perfect answer. You know what the common mistake I see? I see this mistake a lot. Telling me the range of ln x is positive. I saw this so many times. So after you've done this graph, can you still make that mistake? Huh? Can you tell me? Can you still make that mistake if you've done this graph? Jocelyn, do you think you'll make that mistake again? Well, I'm sure you didn't make that mistake before.
No.
You recognize that's a mistake, right?
Yes.
If you have done this graph, the whole thing we went over, right? You will be unable to make that mistake. Thank you. Right? Now let's see. We have fully analyzed e to the power x, right? As x approaching infinity and so on and so forth. So let's see what happens for this e, okay? For this ln x. What is ln x? So when x is approaching 0, first of all, x cannot approach negative infinity because the domain must be greater than 0, right? Some of you already pointed out. The domain for ln x is x must be positive, right? We saw that in the picture, in the making of the picture, making of the table. Do you guys see it? See that? So the domain for ln x is what? X must be positive. So if x is approaching to the limit to the left, it can only be approaching what? Approaching 0 from larger than 0. It can only approach 0 from larger than 0, right? So now I'm gonna put this over here. Domain of ln x, x must be positive. And what is the range? What is the range?
It's
The
all real
range
numbers.
would be negative infinity
Positive infinity.
to positive infinity. To positive infinity. Okay, are there special cases? Yes, we will analyze special cases. That comes later. But for this function, okay, you can see for different input, right? When you have when you have e to the power -2, what is the output? This is the output, -2, -1. That's the output, right? So it could be from negative infinity to positive infinity. Do you guys see that? Do you see that visual? The positive infinity, you know, we're going there slowly, sure, but surely. Do you guys see that? We're going there surely. It's just a little bit slower. It's just a little bit slower. Okay? So the range is from negative infinity to positive infinity. And we should never make this kind of mistake. Terrible mistake. Okay? So that's why I said some of you said, oh, we never done this before. Absolutely. A lot of you have never done this, have never done these graphing before. Do you agree with me? But it's okay. It's not too late. When you do it, how do you feel about doing it? Is it very difficult? Is it very easy? It's in between, right? Is it in between?
Yes.
So once you've done it, you will never make these kind of mistake. Never make these kind of mistake, never. Now, as x approaching 0, okay, as x approaching 0, as x, okay, so I'm going to use the standard notation in mathematics. As x approaching 0 from larger than 0, do you see that little positive sign I put in there? What does ln x approach to? It approaches negative infinity, isn't it? I'm sorry, this may not be visible to you. Is it visible to you? It approaches negative infinity. Do you see that now? So this is the observation as x approaching 0 from larger than 0. See, oh my God. Perfect. Okay, I see Cortland's answers on chat. So please forgive me, you guys. I'm gonna clean this up. Okay. Okay, assuming you have taken the notes, you have marked the points, so on and so forth. Okay. So now I'm gonna make this just a little bit larger. So in the future, if I'm asking you to draw a graph and mark points, you know what I meant, do you? I meant to mark the point the way I did.
Yes.
Okay. Don't come back because I've given quizzes like this and people don't do that. And I give them very low points and they come back to ask me, well, didn't I tell you? Mark the point, meaning mark the points. Mark the points on the graph. Okay. All right, so this is one observation. So I'm going to copy Cortland's work here. Okay, he showed the work on the chat as x approaching positive infinity. Okay, ln x approaches positive infinity. And of course, these are introductory calculus. In calculus class, you're going to learn a lot more other stuff. But this is the things you already see in algebra class, right? These are the things we already have seen in calculus in algebra class. So this is more like introductory calculus. Okay, don't get me wrong. In calculus, you're going to learn a lot of other theories and a lot of other definitions and related theories. But this is just like we already know. You are expected to know by the time you enter calculus. Do you follow me? All right. And what else there is? What else there is? ln x, right? We did ln x. And domain and range summary. Okay. G of x. So I'm just going to summarize this, and we're going to put a table together to summarize this. ln x. The domain is, what is domain?
The domain is all positive real numbers.
Perfect. All positive real numbers. That's a perfect sentence. What's the range?
All real numbers.
Perfect. Shall we summarize what we've done today so far before we move forward? How about x-intercept, y-intercept? Okay, so that's one thing we haven't touched, but what we have done it. Okay, so I'm going to put a summary table together. I'm going to put a summary here. And then we're going to put all of those information together because we want to make sure we understand everything. Okay, one is f of x equals to e to the power of x. And g of x equals ln x, right? And we want to know its domain. Domain, range, x-intercept, y-intercept. Okay, and we're going to bring the picture with us. Right, we're going to bring the picture with us. The domain for e to the power x, what is it? Domain, range, right? We have a one sentence description for domain and range. And what is the domain for ln x? Greater than 0. And the range of real numbers. Okay, so let's look at x-intercept. What is the x-intercept for e to the power x? What is it?
There is no x-intercept.
That's right. There's none. Because the curve is always above the x-axis. It will never touch it. Therefore, there's no crossing. There's no crossing with x-axis, right? No crossing with x-axis. What is the y-intercept for e to the power x?
0, 1.
Perfect answer.
And then for ln x, it's just the inverse, where the x-intercept is 1, 0, and then there isn't a y-intercept.
Was it no y-intercept? Very good. Okay, so can we describe domain in one sentence for e to the power x? This sentence is absolutely essential because I want that to be in your mind. I want you guys to understand this and be able to speak it. It's a very powerful reason for a lot of things. So what will be that domain range in one sentence for e to the power x? Huh?
E to the power x is greater than 0 for any real number x.
Perfect. Perfect. Excellent. Do you understand everything you said? You see? We use language to enhance our understanding. We use our language to enhance our understanding. Okay, as a matter of fact, you can say this in Spanish, Japanese, whatever language you feel is most comfortable. You can speak that to yourself to enhance your understanding. To enhance your understanding, okay? So that's about logarithm for e to the power x and ln x. I think we have covered most of the stuff, which is essential. And of course, the rest, the other thing is the limit, right? The limit. Those other descriptions, for example, we did here for ln x, right? For ln x, if you like, you can put it in there. For ln x. Let's see, where do we put them there? Yeah. Okay. Is that fitting? And we have another sentence. A bit too long. Just put it here. Okay. So what did we summarize? What did we do for e to the power x? That one sentence, right? And this guy here. The examples I said here, I meant to set an example. When you study certain things and you summarize, okay, you summarize, okay, and then you can branch out. That's what we call study. That's what we call study, okay. You study the details and then you put everything together, you summarize, okay. For the next two functions, actually, we're not going to spend time in class. That's yours, okay, which is 10 to the power x and common log x. So the next function is on basic 1 is 10 to the power x. Okay. And what else? Common log x. Oh, there's another thing we forgot to mention, but you guys already know. These two functions are inverse to each other, right? That's right. We don't want to forget that. Okay, they're inverse to each other. Sometimes they're too obvious. We forgot, right? Okay, so let's not forget it. This is these two functions are inverse to each other. Okay, one's domain is the other's range. Okay, so as we said, all pairs of inverse functions, they have the same feature. They have the very same feature. Okay, and you can see that e to the power x, 2 to the power ln x, and 2 to the power x, common log base 2x. They're all similar, aren't they? Then now how about 10 to the power x and the common log x? They will be similar too. So I'm going to leave this part of homework for you, and we're going to transition to trigonometry. Okay, we have 15 minutes left, but we're going to start. We are going to start. Okay, you're gonna do these. Okay, please. Okay, I'm gonna specify. You need to complete your homework, and you need to do everything we did in class by yourself after class. Could you do that for me? Don't say, oh, I already did it in class, therefore I'm not going to do it. No, you need to do it again. You need to do it again all by yourself. Okay, so please complete work. Okay, similar work for these functions. Okay, of course, you know that's part of your homework. So now you know what to do, right? Now you know what to do. And next, trigonometry. Trig review. I trust every one of you had a trigonometry, didn't you? If you didn't have trigonometry, you should not take this class. I'm sorry, because this class cannot replace trigonometry. If you did not have trigonometry at all, you should go back to take trigonometry. Okay, still not too late to sign in for a trig class. You guys understand what I meant? Because my past experience tell me if you didn't have trigonometry, you take this class, you're gonna struggle terribly. And then you're not gonna make it to calculus. You're not gonna make it to calculus class. Even if you barely pass this class, you get into calculus class, your chance of passing calculus class is significantly diminished. I have not seen a student who didn't take trigonometry and pass calculus class. I have never seen a student like that. Okay, so you don't want to waste your time. Just go back to take trigonometry. Okay, it's a 3-unit class. I think we still have that class in session. If you need my reference, and I'll be happy to give you some reference and help you to find that teacher to take that class. Okay, so now let's do trig review. Trig review. On trig review, let's go back to basic 1 table. Let's look at basic 1 table. Let's look at that basic 1 table. The next are trig functions, right? So you will see sine and arcsine. What do we remember about sine and arcsine?
They're the opposite of each other.
They are the opposite of each other. How are they opposite of each other? How are they opposite to each other? How are they opposite to each other? They're inverse functions. Okay, I see some reply. Cortland's reply, they're inverses. They're inverse functions. As a matter of fact, your answers are wrong. Your answers are wrong. Okay, I'm sorry to shock you, but I'd rather give you a straight answer and explain to you why. Okay? Only the 1-to-1 function has inverse. Okay, so now we have all the concept we need. Sine function, as we know it here, is not a 1-to-1 function. Therefore, it does not have inverse. Then you say, well, if sine doesn't have inverse, where does arc sine come from? Well, in trigonometry, you have learned that. You might have forgotten. That's what we are reviewing this for. Okay, and some of you said they're opposite to each other. Opposite, the word opposite in mathematics is only used in one situation. Okay, it's only used in one situation. Say, for example, we say 2, right? The opposite of 2 is what? Is negative 2. The opposite of negative 5 is the positive 5. So for the word opposite, it has a very specific meaning in mathematics. An opposite and inverse are entirely different things, because now we're learning this language, right? Mathematical language has to be very concise. So the word opposite you use here is very vague. It's vague. That's why I'm asking you to explain a bit further. So if you like to explain a bit further, I'll be happy to listen. And but do expect me to critique you, right? Because that's my job, to help you to understand the language better. So the word opposite really is used in this kind of situation. And then you use the word inverse, right? I'm glad you have this word inverse. But unfortunately, these two functions are not inverse to each other at all. We just learned two functions. We have learned functions like 2 to the power x. They are inverse function to each other, right? What are the special features about function inverse to each other? One's domain is the other's range. Can you graph for me what's sine x, what's arc sine x for me? Can you graph these two functions for me? Do you know what's the domain? What's the range for these two functions? We're going to do a lot more work than this tomorrow. Today, we're going to just have an introduction, okay? And of course, your homework is to review these trig functions, okay? Because we're running out of time today. So just today, I'm just asking you these questions because I want to know, what you don't know. Okay, because I know you come from the background of you have taken trigonometry, and we certainly cannot do the entire trigonometry course all over again in this class. We don't have that kind of time. But this is like an introduction, and we get familiar with each other. I know what you know, I try to know what you know and what you don't know. And so could you please tell me what the domain for sine x? And what the domain for arc sine x? And by the way, do you know these two notations mean the same thing? So if you draw the curve, if you draw the sine curve, can you mark a few points for me? If you draw the arc sine curve, can you mark a few points for me? That's the thing, right? I said the minimum 5 points. Can you mark 5 points for me on the graph? That explains that tells me you understand if you mark those 5 points correctly. A lot of our students do not know how to mark those points. If that's you, that's fine. That's what we're here for. Right? So just like what we did with all the previous functions, we're going to do the same for sine, cosine, and arc sine, arc cosine. Can anybody tell me what the domain for sine? Drake, I don't hear you. Are you trying to say something?
I'm really not sure. I don't know why, but like I felt like it was x squared, but I don't think that's right.
Okay, that's okay. That's all right. Okay. I just merely want to get you guys started. Okay, Cortland says 1, -1. What is this for?
So domain for sine, all real numbers.
Okay, we got one correct answer there. Very good. And Cortland says 1, -1. What is that for?
I thought that was the domain.
Okay, so Cortland thinks that's a domain. 1, -1.
Isn't
Any
that
other
just the
answer?
minimum and maximum?
Minimum, maximum for what?
1 and -1,
It's a minimum, maximum for what?
sine of x.
So you mean for the range?
Yeah.
Max? Okay, I'm gonna put your words there correctly. Okay, as you said. Maximum, minimum, min, 1, -1. Any other input? But this is not a range. Okay. But your comment about sine, maximum for sine value is a +1, minimum for sine value is -1. That's correct, but that's not range. Okay, so I'm gonna just make some comments for you, and I want you guys to review this after class today. Okay, and these comments. Okay, so I'm going to give you some feedback. This is wrong. And this is right. These comments are right. But you still didn't give me the range. Okay. So today, I think that's all for today. Tomorrow, we're going to work on the trigonometry functions. Okay, we're going to work on the trig functions. And what I like to show you guys is what to work on. I have some review materials put on Canvas myself. Okay, so let me clean this up. On the module, do you guys see this? Let me share that with you. On the module. Okay, student view. On the module, this is what you see. You see my syllabus, you see my office hours, homework. We have posted these topics. Okay, these are trig reviews. Okay, so these are for you to read. For you to read. Okay, I wrote them up. And I hope you take some time to study these. And the first one is sine, arc sine. Sine, arc sine examples. arcsine and its inverse, and so on and so forth. Okay, so take your time, start reading it, and you still have your, if you, whatever form of trigonometry textbook you have, it doesn't have to be, the official one. Any trigonometry textbook you have, you probably like to start reading them. Okay, and tomorrow I will help you with the review. Got it? And so that's your homework. You start working on those to look for this information and figure out why. And I'll see you guys tomorrow. Okay? Very
you.
good job. Thank you. Very, very good job. Very good participation. Okay, I'm so proud of you for participating and be part of this class. And thank you for showing your face to me. Okay, that gave me tremendous joy to see everyone is around. Okay, for those of you who don't have the webcam, that's okay. And as long as I can hear your voice and you're participating, I'll be so happy. Okay, so I'll be in my office hours. I'll be in my office hours, so please do come to my office hours if you need to. See you tomorrow.